Ninja Warriors, welcome to yet another power-packed session, and in today's session we are going to discuss all the previous year questions from the chapter complex number from January attempt. Okay, so January attempt there were 10 question papers, and in these 10 question papers we have found that 14 questions were from complex numbers. What does that mean? That in January approximately 1.4 questions were there in each paper. Now 1.4 question means what? So minimum one question you will see in your upcoming JEE Main, and maximum 2 questions you will see in your upcoming JEE Main 2025 from the chapter complex number. Okay, so today's session is all about January attempt, and April attempt also we will do. So there were 9 questions, that will be a separate session. Okay, so let's start with the very first question. Okay, so let's just find some very easy question. So I just want to solve the very first question, which is the easier one. Okay, let us quickly go to the easy question, alpha question. Let's start with the basic question. Okay, so this question is actually talking about the geometry of complex number, and moreover the geometrical significance of modulus. So let me just tell you the concept involved in this. Okay, the geometry involved in this. The concept says that if you have modulus of z minus z naught, what does that mean? So this z naught is a known complex number or a known point, but this z is unknown. So this means that this expression modulus z minus z naught means distance of z from z naught is r. This is the geometrical significance. What does that mean? So there is a z naught, which is the center, you can say, and there is a moving point z. So basically z represents a circle. Okay, because r is what? The radius. So you take any point on this circle, which is z. Now from this point z naught distance will always be radius. Okay, so basically mod of z minus z naught is what? Distance between z and z naught. I hope that you understood this point. Let us apply this over here. So now what about this? This is distance between z and iota. What is iota? Iota, if you carefully observe, iota is actually 0 plus iota, that means 0, 1. So z, distance between z and 0, 1 is equals to distance between z 1 is equals to distance between z and, now this is 1, right? 1 is what? 1 plus 0 iota. So 1, 0. Okay, so let's just plot these 3 points and understand what this geometry is trying to tell us. So 0, 1 is here, 0, minus 1 is here, and 1, 0 is here. So we are looking for a point z, right? Now distance between z and 0, 1. Distance between z and a, distance between z and b, distance between z and c should be equal. So I am looking for a point whose distance from a, b and c are equal. Okay, so there is a term in triangle, right? There is a center in the triangle. Okay, so there is this definition which says that circumcenter is that point whose distance from the vertices is equal, right? And that's what we are looking for. Distance from A should be equal to distance from B should be equal to distance from C. That point, what is that point, ma'am? Circumcenter. So that means Z is nothing but circumcenter of the triangle. It's a unique point. So circumcenter, now circumcenter is 1 point. So set S will have only single point. So how many points will be there in set S? 1 point. Okay. All right. So geometry explains about this question. Let us move on to the next problem, which is another easy problem I'm looking for. Okay, this problem. Okay, very good problem. Yes, so z equals to half minus 2 iota. So z is given as half, minus 2. Now z plus 1, modulus z plus 1 is equals to this. So clearly we have our z. Why don't we do one thing? We just plug in the value of z and calculate the modulus and everything. Okay. So over here on the right hand side, modulus of half plus, sorry, minus 2 iota plus 1 mod close alpha z. Alpha z, z is what? Again half minus 2 iota bracket close plus beta 1 plus iota. Okay. So on the left hand side, we are looking for modulus. So modulus of half plus 1 is 3 by 2 minus 2 iota is your left hand side. What about right hand side? Now I want my right hand side to become the real part separate and imaginary part separate. Okay. So alpha by 2 plus beta, and this is minus, okay, plus iota minus 2 plus beta. Correct. So on the right hand side, we can see this is the real part. This is the imaginary part. On the left hand side, if you calculate, this is the modulus. See, modulus of any quantity is always a real number because modulus formula, you know, 3 by 2 square plus 2 square. This is your left hand side. Right hand side is alpha by 2 plus beta. And what about this? This should be equals to 0. Why? Because if you want to equate both left and right hand side, what will happen? The imaginary part should be 0 because left is all real. The right should also be all real. That comes down to beta is equals to 2. So beta is 2. Now we're just looking for alpha, right? So beta is equals to 2. So this is 0. Now we are having alpha by 2 plus 2. This is your right hand side. What about left hand side? So this is 9 by 4 plus 4 root. So 9 by 4 plus 4 root. 4 4s are 16. So this is 5 by 2. So basically 5 by 2 is equals to alpha plus 4 by 2. Clearly alpha is coming out as 1, right? So alpha is 1, 1 plus 2, 3 is absolutely correct. Okay, so this question also done nicely. All right, perfect. Now let us have a look at this question, which is talking about roots of the quadratic equation. So again, it is a combination of quadratic and complex numbers, right? Alpha and beta are the roots of this equation, correct? With imaginary part of alpha is greater than imaginary part of beta, okay? And now we are looking for this value, okay? So we have seen such expression in our grade 10 also. A quadratic equation is given. We can easily calculate alpha raised to power 4 plus beta raised to power 4, right? Okay. And another aspect is this, the remaining two terms, which are alpha power 6 minus 5 alpha square, okay? So x square minus x plus 2 equals to 0. We know that alpha and beta are the roots. We are looking for what? Alpha 6 minus 5 alpha square. Let us talk about this here, and let us talk about this in a separate expression. Then in the end, we will add these two expressions, right? Okay. Now alpha square, if I take common, I will get alpha power 4 minus 5. Perfect. Now just understand, alpha is root of this, right? So can I just write alpha square minus alpha plus 2 is equals to 0, or rather alpha square is equals to alpha minus 2. We'll make use of it and reduce this expression. Alpha square is alpha minus 2. Alpha power 4 is what? Alpha square whole square. So alpha square is alpha minus 2 and one more square, minus 5, right? This is alpha minus 2, alpha square plus 4 minus 4 alpha minus 5. So this is alpha minus 2 and this is alpha square minus 4 alpha minus 1. Alpha minus 2, this is alpha square is again alpha minus 2 minus 4 alpha minus 1. Alpha minus 2 and this is minus 3 alpha minus 3, okay? Finally, 3 we can take common. In fact, minus 3 if I take common, this is alpha minus 2, alpha plus 1. So now this is minus 3 alpha square minus alpha minus 2. Minus 3 alpha square is what? Alpha minus 2 minus alpha minus 2. So this is alpha alpha gone, minus 3 into minus 4. So this is minus plus 12, plus 12, plus 12, okay? So this is sorted, okay? This part is plus 12. Now what about this? Alpha power 4 plus beta power 4. For that, to get this, we need to talk about alpha plus beta first. We know that alpha plus beta whole square is alpha square plus beta square plus 2 alpha beta, correct? You know that alpha plus beta from here, sum of roots is what? 1. So 1 is equals to alpha square plus beta square plus 2 alpha beta. Product of roots from here is 2 by 1, 2. So alpha square plus beta square is coming out as minus 3. Now square it both the sides. So again, if you square both the sides, alpha 4 plus beta 4 plus 2 alpha beta whole square is equals to 9. You're looking for this value. Alpha 4 plus beta power 4 is equals to 9 minus 2. Alpha beta whole square is 1 more 2. So this is coming out as 1. Alpha 4 plus beta 4 is coming out as 1. So this is your 1. And combination of these two is what? 12. 12 plus 1, 13 is absolutely right. Okay. So this is how we do this. We actually reduce the expression by using this expression. Okay. All right. Clear? Okay. Perfect. Now which question? Let us talk about this question. Okay. All right. If alpha satisfies the equation x square plus x plus 1 equals to 0. Now understand. This equation has roots omega and omega square. Right or wrong? Omega and omega square are the roots of this equation. Correct? Okay. So we know that omega and omega square are roots of this equation. We know certain things about omega. First thing is omega cube is 1. Second thing is 1 plus omega square is 0. Only two things we need to know about the omega. Okay. Now what we will do is, so alpha. So this is again, either this is alpha or this is alpha. You take anything, you will get your answer. Okay. Now what they are asking is this equation. Sorry, this is C alpha square. Perfect. They are asking about this. That you put left hand side is alpha. Alpha you know is omega or omega square. You put anything, you will get the same answer. Okay. So 1 plus omega. Let's take alpha is equals to omega. 1 plus omega power 7 is equals to A plus B omega plus C omega square. Right. And A, B, C are non-negative quantities. 1 plus omega from here we can say is minus omega square power 7. Okay. So this is minus omega raised to power 14. And you know that omega power 14 can be written down as omega to power 12 and omega square. Correct or not? Omega power 12 will be 1 because if omega cube is 1, then omega power 6, omega power 9, omega power 12, all the multiple of 3 will be 1. That's why we separated like this. 14 is 12 plus 2. 12 is multiple of 3. So this is minus omega square on the left hand side, and on the right hand side it is A plus B omega plus C omega square. Right? So one way is you keep A 0 and B 0 and C minus 1, but that is not possible. Why? Because C cannot be minus 1. So we need to think about a different approach. Minus omega square, if you are seeing right here, can be written down as what? From this relation, 1 plus omega. And this will be equals to A plus B plus C omega square. Now compare. Clearly the constant term will be 1. Coefficient of B, coefficient of omega, if we compare, B is also 1. Now C is 0. A1, B1, C0. Now this makes sense as per the question. Now let us plug in and check. 5, 3A. 3A is 3. 2B. 2B is 2 minus 0. So 3 minus 2. So this is 5. This is actually coming out as 5 only. 5 is the correct answer of this question. Okay. All right. Now let us talk about the next question, which is this. Okay. So a little bit lengthier questions will come on the way. Now be prepared that questions will be a little bit lengthier now on. Okay. So here set S is equals to this. Mod Z minus 1 equal to 1. Okay. So this is basically a circle whose center is what? 1, 0 and radius is 1. So this is the circle. Okay, all right. I can write also x minus 1 whole square plus y square equals to 1. This is the circle, right? Set S. Okay. Now what about this? Straight line. You don't agree? Let me tell you. See, z plus z bar you know is 2x, right? Z minus z bar is what? 2y iota. Okay, so let's put these values. So now this line root 2 minus 1 z plus z bar is 2x minus iota. This is 2y iota is equals to 2 root 2. 2 I am getting I'm cancelling 2 2 2. So this is root 2 minus 1 x plus, now iota square is what? Minus 1. So that's why a plus sign is here. So this is your line. A line is there and a circle is there. Okay. Line and circle are right here. Cool. Now what they are saying is Z1 and Z2 belongs to S. Okay. So basically what we are looking for is, if you carefully read the question, this set S is having all those points Z which are lying on the circle and which are lying on this line. That means the common points of circle and line. So if we just talk about circle and a line, there are two common points. Okay. So Z, there can be one common point also. If it is a tangent, there can be zero common point also. Okay. So, but we prefer that we assume that there are 2 points that we will solve, and then we will understand whether there are 2 or not. Now they are also saying, question also says Z1 and Z2 is in this set S. So Z1 and Z2, this is Z1, this is Z2, 2 points, intersection of circle and line, such that Z1 is maximum of mod Z and Z2 is minimum of mod Z. Okay, all right. So there are 2 points. Now modulus of that, so there will be 2 points. Both will have their individual modulus, right? So whose modulus will be maximum, that will be counted as Z1. Which modulus is minimum, that will be counted as Z2. Okay, and we are looking for, now you just pick that which one is Z1, maximum one is Z1, minimum one is Z2, and you need to figure out this value. Okay, all right. So yes, I guess we have understood this. Now let me just write down nicely that set S will have 2 points. Set S will have 2 points, Z1, Z2, in such a way that both the points Z1 and Z2 are intersection points of circle and line. This is your circle and this is your line. So we just need to solve circle and line and check what Z1 and Z2 we are getting. So let's do that. Circle is mod, so circle we have already figured out. This is your circle, and line also we have already figured out, root 2 minus 1 x plus y equals to root 2. Correct? So solve it out. You will get the answer. So now if I open this, x square minus 2x, 1 getting cancelled out, plus y square equals to 0. X square minus 2x plus y square. What is y? So y from here will be root 2 minus 1 x. Correct? So root 2 minus 1 x square equals to 0. X square minus 2x plus 2, then we are having plus root 2 minus 1. So this is square. So x square ka coefficient will be square of this. 2 plus 1, 3 minus 2 root 2 and minus 2 root 2 minus 1 x equals to 0. We just need to solve it. Okay. So now let's club them together. This and this. So x square coefficient will be 1 plus 4 minus 2 root 2. Club these two together. So minus, let's take minus common, 2, then multiply. This is plus 4 and minus 2 root 2. X plus 2 equals to 0. So x square, now let's take 2 common. So this is 2 minus root 2 minus this is 4 plus 2, 6, 2 is coming common, 3 minus root 2x plus 1 equals to 0. This is the quadratic. Okay. All right, now if you solve this quadratic, what will you get? You will get, can you see x equals to 1 is getting satisfied. And another root will be what? See, product of roots is what? 1. Sorry, product of roots, alpha beta is 1 upon 2 minus root 2, c by a, 1 upon this, right? One root is 1, you can clearly see it is satisfying. One root is 1, another root, so I put alpha equals to 1. So beta will be 1 upon 2 minus root 2. This you can also solve by splitting the middle term as well. Okay, x1 and x is 1 upon 2 minus root 2. Okay, so now the moment you put x equals to 1, what will you get? X equals to 1 in here. Put x equals to 1. You will get y equals to root 2 minus root 2 plus 1. That's it. So y is equals to 1. x1, y1. Okay. Now x will be this 1 upon 2 minus root 2. The moment you put x equals to 1 upon 2 minus root 2, what will you get? Y equals to root 2 minus root 2 minus 1. Now x will be 1 upon 2 minus root 2. Okay. So y will be equals to root 2 minus. Understand, root 2 minus 1, what about this? If I take root 2 common from the denominator, I will get root 2 minus 1. So this is root 2 minus 1 by root 2. So this is your y. So from here, y is root 2 minus 1 by root 2. Correct? Z1 and Z2 are clear. Okay, so Z1 comma Z2 is coming out as 1 plus iota, and another one is 1 upon 2 minus root 2 plus iota times, what is y? Root 2 minus 1 by root 2. This is your Z1 and Z2, right? Now modulus Z1, modulus of this is what? Root 2. Modulus of this will be what? If you, So you have to calculate the modulus, okay? So clearly that if you calculate the modulus, because you need to understand that what is Z1. So this will be your Z1, because this modulus will be maximum, and this will be your Z2, correct? Now you're looking for root 2 Z1. Sorry, not this. Sorry, my bad. This is your Z2 and this is your Z1. Z2 and Z1. Okay. All right. Now Z1. So root 2 times Z1. So root 2 times Z1. So root 2 times Z1. 1 minus 2 minus root 2 plus iota times root 2 minus 1 by root 2. Minus Z2. So 1 minus 1 plus iota mod square. Solve it out. Multiply. Root 2, 2 minus root 2, correct, plus iota. So root 2 into root 2 is 2. So 2 iota, and this is root 2. If you multiply, so minus iota, that's it. Minus 1 minus iota, correct? And this is square. So clearly, this is 1 iota, this is minus iota, this is getting cancelled out. So we are left with, finally we are left with, so root 2 if you take common, this is 1 upon root 2 minus 1 and minus 1 mod square. So this is actually root 2 if you take rationalize, root 2 plus 1 minus 1 whole square. So root 2 square is your final answer. So 2 is absolutely right, option D is absolutely right. Okay, clear? So a little bit lengthy question, I already told you, but yeah. All right, the question says that let P be a set of all complex numbers which satisfies this thing. Okay, so we need to understand the geometry behind this. Number one, Q be a set of all the complex number which satisfies this thing. Again, we need to understand the geometry behind this. Now, P and Q, we can actually shade the common region of P and Q. Why common region? Because we are looking for P intersection Q. Okay. So in P intersection Q, we are looking for those values wherein those values of Z or those points Z which this thing becomes, for which these things become maximum and minimum. Right now, you won't understand much. You will only understand things once you start plotting the things nicely, okay? So first of all, what is this? Hold on. Yeah, what is this? This is actually distance between Z and this is distance between Z. You know the geometry, right? Z and minus 2, 3. Okay. Distance between Z and minus 2, 3. So let me just draw a straight line. Okay. Now this is minus 2. Minus 2 will lie over here. And this is 3. Right? And radius is 1. Perfect. Let me draw a circle now. Right. This is the circle. Correct? Okay. So now Z comma minus 2 by 3. This is a circle whose radius is 1. And now we are looking for less than or equal to. What does that mean? That region which this P set will have is nothing but on the circle and inside the circle. On the circle and inside the circle. This is the region. Because the sign is less than. Clear? Okay. All right. What about this Q? So Q, if I talk about Q, again, Z 1 plus iota. So Z into 1 plus Z bar. Plus iota, if you take common, this is Z minus Z bar less than or equals to minus 8. We are talking about Q here. This is 2x plus iota. This is 2 iota y less than or equals to minus 8. X minus y less than or equals to minus 4. Okay, so x minus y less than or equals to minus 4 is a straight line. And that straight line which has x intercept negative minus 4 but y intercept positive. So the line looks like this. The line looks like this. Clear? Okay. Now again less than sign. Now you have to understand that which region this thing is talking about. The upper region or the lower region. Upper region and lower region doesn't make any sense. Region which contains origin or region which does not contain origin. Very simple method I will tell you to identify whether this less than signifies this region or this less than or equal to sign signifies this region. Okay. We have two options. Okay. Two sides of line. So clearly if I just put 0, 0 in this, so it will become 0 less than or equals to minus 4, which is a false statement. That means origin will not be in our required region. Other than origin will be in region. So finally, the common portion of P and Q, because P is on and inside the circle, and for line, I am talking about only this region. So clearly the common region, if you check now, it will be this circle, this portion of circle. This is common region. Understanding? Clear? Let me just shade now. This is the common region. Okay. This is the common region. P intersection Q. Right? So RZ will lie on the circle, on this circle, this portion of circle, or inside this, this circle, the upper half of the circle. Clear? Okay. Now, like, but again, we need to get the exact z. So now this is the new thing. This says that modulus of z minus 3 plus 2 iota. So basically this says the distance between z and 3 comma minus 2 should be maximum. Distance between z and 3 comma minus 2. Now 3 comma minus 2 will lie somewhere over here. You want a point in the shaded region which is minimum distance from this 3 maximum distance from 3 comma minus 2. Clearly, if you just plot the line, right, minimum and maximum region always lie along the common normal. So we have plotted a normal to the circle and this point. Clearly, the minimum distance between this point P, let's say, P we can't take, let's say A, and this shaded region or inside the region, the minimum will be happening when your Z becomes this point. So minimum is Z2, right? So this will be your Z2 and this will be your Z1. Okay. So Z2, to get Z2, what you need to do is, to get Z2, you need to actually solve the line which is x minus, so this is L1. For Z2, you solve L1 and this line, let's say L2. To get Z2, you need to just solve L1 and L2. This is the intersection point of L1 and L2. To get Z1, tell me what will you do? What will you do to get Z2? Sorry, Z1. Z1 is maximum distance. Maximum distance is this. That means you're looking for this circle and line 2. Just solve these two together and you will get your answer. Let's just do it. Okay. L1 equation we have, we just need to write the L2 equation. To write the equation of L2, we need a point and that we already have, y plus 2 equals to slope x minus 3. Now what is the slope? So clearly it is perpendicular. These two are perpendicular lines. Okay. So now the slope of this line is 1. Slope of this line will be minus 1. So y plus x equals to 3 minus y plus x equals to 1. This is your L2. So you need to solve L1 and L2 clearly to get, so L1 and L2, let's do that. X minus y equals to minus 4, x plus y equals to 1. Just add. So this is minus 3, x equals to minus 3 by 2. The moment you put x equals to minus 3 by 2, your y will become 5 by 2. This is your, which point, tell me? So this is your Z2, as simple as that, as possible. Now for Z1, you need to solve circle. Circle is what? Okay. Circle is x plus 2 whole square and y minus 3 whole square equals to 1. And L2 is what? This is C and L2. L2 will be x plus y equals to 1. If you solve these two now, so it will take some time, but you have to solve it. So your x will become, I have solved it already, minus 2 minus 1 by root 2, comma 3 plus 1 by root 2. This is x comma y. So this is your Z1. Now that you have got your Z1 and Z2, okay, so what they are looking for is mod Z1 square plus 2 mod Z2 square, okay. So mod Z1 square plus 2 mod Z2 square is what you're looking for. The mod Z1 square, so we have to take some time for this, but mod Z2 square, first of all, we can calculate. This is 9 by 4 plus 25 by 4. Mod Z1 square will be what? So this is 2 plus 1 by root 2 whole square plus 3 plus 1 by root 2 whole square. Perfect. Okay. All right. Clear? So if you solve it, 4 plus 9, 13 plus 1 by 2 plus 1 by 2 plus 1. Here it will be 2 2s are 4 by root 2 and this is 6 by root 2 plus. Now this will be what? 25 plus 9, 34, right? 34 by 2 is 17. So now this is 31 plus 6, 7, 8, 9, 10. 31 plus 10 by root 2 is your answer. Let us check. Alpha plus beta by root 2, so we need to rationalize. So this is 31 plus 5 root 2. 31 comma 5. So 31 comma 5. So 31 plus 5 will be 36 as the final answer. I hope that is clear. Okay. This question also done nicely. And now we are having another question on our screen which says, if z is a complex number such that mod z is greater than or equal to 1. Mod z equals to 1 means what? Mod z minus 0 equals to 1 means what? That distance from z, this distance of z from the origin is greater than or equal to 1. That means the region is lying on the circle and outside the circle, not the inside one. Clear? Mod of, minimum value of mod of z plus half 3 plus. So basically, distance between z and minus 3 by 2 comma minus 2. The minimum value of this we are looking for. Okay, distance between z. Where is z? Z is outside the circle, anywhere. Infinite region. Okay. So now this is your minus 1. Minus 3 by 2 will come over here. This is minus 2. And this is 8. This is the point. And this is the region. Right? Okay, this is the point. Okay, so now minimum region is obviously, so z can also be minus 3 by 2 comma minus 2 because z is actually, this point is lying on that region. So minimum distance, minimum possible distance cannot be negative. Can it be 0? Yes. Is that possible? Yes. So minimum distance is 0. So that's why option D is absolutely correct. Okay, clear? All right, let us talk about this question. Now this question, okay. Let the complex number alpha and 1 by alpha bar lie on the circles this and this respectively, where z0 is given as 1 plus iota. Okay. Then we are looking for the value of 100 alpha square. Okay. So there is a technique. In this question, I'm going to use one technique and one very important identity, which is z bar equals to mod z square. Yes, z bar is mod z square, right? So now mod z, can you see mod z square? And alpha lies on this. That means I can replace z by alpha. And here 1 by alpha lies on it. I can replace z by 1 by alpha bar. I will do that, but I will first of all make use of this identity, which is z bar is mod z square. So mod z square, right, can be written down as, so z minus z naught whole square is equals to 4. Alpha lies on it. Alpha minus z naught square equals to 4. Now apply the identity. Alpha minus z naught bar equals to 4. Alpha minus z naught, alpha bar minus z naught bar equals to 4. Basically, conjugate property I've used. Now multiply. Alpha bar minus alpha z naught bar minus z naught alpha bar, minus z naught bar equals to 4. So this again I can use property. Alpha bar will be what? Using this property alpha square, mod alpha square. This is minus alpha z naught bar minus z naught alpha bar, and this is minus mod z naught square equals to 4. Okay. All right. So similar thing we can do with this. 1 by alpha bar we can satisfy. So 1 by alpha bar minus z naught whole square equals to 16. Correct? So now this is going to become again 1 by alpha bar minus z naught. 1 by alpha bar minus z naught whole bar equals to 16. Again that property. 1 by alpha bar minus z naught is as it is, and this is 1 by alpha minus z naught bar equals to 16. 1 upon alpha bar minus z naught bar by alpha bar minus z naught by alpha plus z naught square equals to 16. What is this? Again alpha bar. 1 by alpha square ka mod is this. So this is All right. Clear. 1 by alpha square minus mod z naught square. Tell me, mod z naught square, can you see it is root 2 square. So this is coming out as alpha square minus alpha z naught bar minus z naught alpha bar. This is actually plus. This is also plus and this is 2. So this is equals to 2. This is the first equation. Okay. Second equation, right? Let me just Okay, so can I do one thing in this? Can I take LCM? Okay, or yeah, let's take LCM for this. Okay, hold on. Yeah. Right, so this is actually becoming 1 upon mod alpha square minus z naught bar alpha upon alpha bar minus z naught alpha plus 2, so plus 2. Actually, this is equals to 40. Now, understand one thing. What I'm going to do is not taking LCM, but multiplying mod of alpha square left and right, both the sides basically. So this is becoming 1 minus mod alpha square z naught bar upon alpha bar, correct? Minus z naught by alpha, again mod alpha square equals to 14 mod alpha square, correct? Now understand this alpha square, mod alpha square can be again written down as what? Alpha bar. Yes or no? Again, this is also alpha bar. So here alpha bar cancel. 1 minus alpha z naught bar minus z naught. Again, alpha cancel. Alpha bar equals to 14 mod alpha square. This is our second. Let me just write it over here. 1 minus alpha z naught bar minus z naught alpha bar equals to 14 mod alpha square. Now subtract these two. The moment you subtract, no, then what will happen? These things will get cancelled out. So mod alpha square minus 1 is equals to 2 minus 14 mod alpha square. So this is 15 mod alpha square is equals to 3. So you are looking for 100 alpha square. So this is 1 by 5. Multiply 100, you will get 20. So 20 is absolutely correct for this particular question. Okay. All right, now let us move on to the next problem. All right, so this question says, let r and theta be the modulus and amplitude of the complex number this. Okay, so modulus to be, it's very easy to calculate, right? Mod z equals to square root of 2 square, that is 4, that is real part square, and imaginary part square. Mod z will be now 2 will come out, square root of 1 plus tan square 5 pi by 8. So this is 2 root sec square 5 pi by 8 to mod sec 5 pi by 8. Mod is there, okay? Now, if you do not consider the mod, then you might feel that, okay, option C is absolutely right. But understand, 5 pi by 8 is lying in third quadrant. Okay. Sec 5 pi by 8 will be a negative quantity. Sec of angle which is in third quadrant, negative. But modulus can never be negative. So we need to make this positive, right? Either the answer is 2 mod sec 5 pi by 8, but it is missing from the answer. Modulus is not there. We have only option is just make it automatically positive without even mod. So now 2 sec 5 pi by 8 is there, right? So basically, yeah, you know that sec 5 pi by 8 ko we can actually, so this is sec 5 pi by 8. Sorry, this is in second quadrant again, but even if it is in second quadrant, no, then also it is a negative angle, right? 5 pi by 8. Is it in second quadrant? Yeah, 5 pi by 8. Now we need to make this angle in the first quadrant. How do we do that? Okay. So 2 sec pi minus 5 pi by 8. Let's do that. So this is going to become sec 3 pi by 8. And now 3 pi by 8 comes in which quadrant? First quadrant. So sec 3 pi by 8, that is third and fourth are wrong. Either this or this is correct. Now we need to look for amplitude. Amplitude is tan inverse. So understand. Tan 5 pi by 8. So again it is a negative quantity, right? So your angle should be in first quadrant, right? So 3 pi by 8. So this is also wrong. This is also wrong. See, 2 tan 5 pi by 8 is a negative quantity, right? What does that mean? X and Y both are positive, right? Minus sign. 2 tan 5 by 8 automatically negative. So both X and Y are positive. That means if both X and Y are positive, that means angle is in first quadrant. Only angle which is lying in the first quadrant is 3 pi by 8. Okay, so 3 pi by 8 option 1 is absolutely right in this particular case. Okay. All right. Now let us move on to the next problem, which is from the topic Euler's form of complex number. Okay. Let me show you. So first of all, this is the quadratic equation whose roots are alpha and beta. Let us calculate alpha and beta. And we are here to calculate alpha beta values only. So alpha comma beta will be equals to root 6 plus minus square root of b square 6 minus 4 3s are 12 upon 2. Alpha comma beta will be equals to root 6 plus minus, this is iota root 6 by 2. Now root 6 if you take common by 2, this is going to become 1 plus minus iota. Correct or not? Okay. This is alpha comma beta. Perfect. Now, so any complex number x plus iota y can be written down as r e raised to power iota theta Euler's format. We are trying to do that. So first of all, alpha. Let us write down the alpha. Root 6 by 2. 1 plus iota can be written down as cos pi by 4 plus iota sin pi by 4. Can I do that? Right? And this alpha can be written down as root 6 by 2 e raised to power iota pi by 4. This is your alpha, by the way. Beta will be root 6 by 4, and now this is going to become 1 minus iota, right? 1 minus iota. So this is e raised to power minus iota pi by 4. This is your beta. Okay. So alpha beta, I guess, sorted to it too. Now we need to look for this expression, which is alpha power 99 by beta plus alpha power 98. That is actually equal to what? 3 power n a plus iota b. Let us solve the left hand side. Let us plug in the values. Alpha power 98 can be taken common. Yes. And this is alpha by beta plus 1. Alpha by beta we can easily calculate. Alpha power 98, yes. Alpha by beta. So this is root 6 by 2 e raised to power iota pi by 4. Root 6 by 2 e raised to power minus iota pi by 4 plus 1. That's it. So this is going to be root 6 by 2, root 6 by 2 cancel. This is e raised to power iota pi by 2 alpha power 98. Now alpha is what? Root 6 by 2 power 98. E power iota pi, so 98 pi by 4 iota. Correct? And this is plus 1. Finally, you will have, so root 6 power 98 will be 6 raised to power 49 upon 2 raised to power 98 will be, or rather we can do root 6 by 2 is by 2. So we can do one thing, root 2 by root 2. Correct? So this is, okay, let it be. 6 power 49, perfect. And this is 2 power 98, correct. And this is e raised to power 49 by 2 pi iota, and this is e raised to power iota pi by 2. So cos pi by 2 0 plus sin pi by 2, so iota only. This is iota plus 1, correct. Now this 6 raised to power 49 is what? 3 raised to power 49, 2 raised to power 49 upon 2 raised to power 49, 2 raised to power 1 more 49. Basically, this is coming out as 3 by 2 raised to power 49. Okay. Now this 1 plus iota is already there. Now 49 pi by 2. Correct? So this is going to become cos 49 pi by 2 plus iota sine 49 pi by 2. Okay. 49 is what? 48 plus 1. Right? So basically cos 2 pi plus pi by 2. It is happening. So again 0 plus this is 1 more iota. So 3 power 49 upon 2 power 49. 1 plus iota is already there. And what about this? Oops, hold on. I have made a mistake actually. No. I have made a mistake. Hold on. So the mistake is 1 plus iota will be root 2. Root 2. 1 root 2 is already involved. Now if you rationalize, the root 12 by 2. Now the root 12 by 2 is what? 3. So this is beta is actually 3 root 3 e raised to power minus iota pi by 4. And alpha is root 3 e raised to power iota pi by 4. Correct. So root 3 was already there. There was no 2 ever. There was no 2 ever. This is also root 3. And yeah. One more time I will explain you, okay? So root 3 cancel. Alpha is what? Root 3 e raised to power 98 into 40 into what? Iota pi by 4. Correct. Root 3. Hold on. So root 3 e raised to power iota pi by 4 raised to power 98. This is e raised to power iota pi by 2 plus 1. That's it. Root 3 power 98 is 3 power 49. This is e raised to power 49 pi by 2 iota. This is iota plus 1. Now this is going to be 3 raised to power 49. E raised to power 49 pi by 2 is cos 49 pi by 2 iota sine 49 pi by 2. And iota plus 1 was already there. 3 raised to power 49. This is iota and iota plus 1. Now multiply. 3 raised to power 49 minus 1 plus iota. Now if you compare clearly, n is 49, a is minus 1, b is plus 1. n is 49, a is minus 1, b is plus 1. So 49 exactly is the correct answer of this question. Okay. All right. Perfect. Now we are having next question, which says z is equals to x plus iota y satisfies this equation. Then we are looking for mod z square. Okay. So very first thing which we are going to do that is z square is equals to iota mod z, iota z bar. If you take mod both the sides, mod here, so it will become mod z square is equals to now iota z bar mod is z bar only, right? See, so iota z bar mod iota mod z bar. Mod iota is 1, mod z bar is z, mod z bar is what? Mod z. Right? So this is the first equation which we are getting. Okay. All right. Now clearly with the use of the property z raised to power, with the use of the property I can do that mod z square minus z is equals to 0. This implies either mod z is 0 or mod z is 1. Now mod z 0 means what? Both x and y are 0 at the same time, which is not possible. So this is rejected. That means mod z is 1. If mod z is 1, then clearly this equation becomes 1. So 1 is the absolutely right. Option B is absolutely correct. Got it? Okay. Chalo. Let us move on to the next problem, which is z is a complex number. Then the number of common roots of this equation is what we are looking for. This and this. Okay. So if you understand this nicely now, Solving this equation is not a cakewalk. It's not an easy thing. But solving this cubic equation is absolutely an easy thing. In fact, I can clearly see that z equals to -1 is satisfying over here. Okay, that means z plus 1 is a factor, right? Hold on. Let's do one thing. Let's take z square common from here. You will get z plus 2. Z plus 2. Okay. Hold on. Not like this. Z cube plus 1, let us stay together. 2 dash z square plus z, let's stay together. Now factorize. Z cube plus 1 is z plus 1. Z square minus z plus 1. Here if you take z common, 2z plus 1. Sorry. Take 2z common. 2z common. So this is z plus 1 equals to 0. Z plus 1 if you take common, this is going to become z square plus z plus 1 equals to 0. Clearly, there are 3 roots of this equation, -1, omega and omega square, right? Now, number of common roots, so 3 roots hai. So we just need to satisfy and check one by one whether -1 is satisfying, whether omega is satisfying, whether omega square is satisfying. -1 if you put in place of z, clearly this is -1 plus 1 plus 1. So -1 clearly is not satisfying, okay? So 3 roots are not possible. Now omega square. So if you put omega power 1985 plus omega power 100 plus 1. 1985. So what about 1984? 9 plus 1, 10. 10 plus 12 is 22. No, actually this is omega power 1983 omega square plus omega 99 plus omega, this is plus 1. This is 1, this is also 1. Finally, omega square plus omega plus 1. And that is 0. That means omega is getting satisfied. Same if you check for omega square. So now omega square will be omega power 2 into 1985 plus omega power 200 plus 1. So this is actually omega square plus 1. 1985 into 2. So this is 3970, correct? 3969. So this is omega power 3969 dot omega. So this is again 1. Omega plus omega square plus 1 becoming 0. That means omega and omega square both are getting satisfied. That's why option B is absolutely correct for this question. Okay. All right. Clear. Perfect. If you've understood this, good. Okay. And if you've not understood it, rewatch it. Redo it on your own. Okay. Chalo. Now next question. If alpha denotes the number of solution of this and beta is mod z upon argument of z, where z is given as this. We are looking for then the distance of point alpha comma beta from this line. Okay. Alpha and beta we are looking more or less. Alpha, calculation of alpha is very easy. So this 1 minus iota mod is root 2 power x is equals to 2 power x. 2 raised to power x by 2 is equals to 2 raised to power x. Now, if you check this, x equals to 0 will be the correct answer. So, alpha has how many, like, number of solution of this equation? So, only one solution. Same, let's talk about beta first. Let's just calculate beta, right? Let's just calculate z first. So, z is pi by 4, 1 plus iota power 4. This is 1 minus root pi iota upon root pi plus iota. Okay. And we are having plus root pi minus iota upon 1 plus root pi iota. Perfect. Okay. Now what we need to do is, let me just write it a little bit on the plus because I want to rationalize. Root pi minus iota, 1 plus root pi iota. Now, rationalize. Root pi minus iota, root pi minus iota. Root 1 minus root pi iota, 1 minus root pi iota. Okay. So, z is pi by 4. 1 plus iota raised to power 4. Now, rationalize. So, this is root pi plus iota. Root pi minus iota is a square, that is pi, minus b square. So, minus iota square is plus 1. Now, multiply. So, minus iota. Okay. Then, root pi minus iota. Minus pi iota. Then this is minus minus plus, so minus root pi. Plus, what about this? 1 plus pi again. So this is root pi minus pi iota. Then we are having minus iota plus, okay, actually it is minus because minus minus plus, but one more iota square is already there. So this is root pi. So now we can just think about cancellation of the terms. Root pi cancel, root pi cancel. Okay. From here, if I take minus iota common, it will become pi plus 1, pi plus 1. From here, if I take again minus iota common, pi plus 1, pi plus 1. Gone. Minus 2 iota. So basically, z is coming out as minus 2 iota by 4, 1 plus iota power 4. Now, 1 plus iota power 4, 1 plus iota square is what? Z will be equals to minus iota by 2. 1 plus iota square is 1 minus 1 plus 2 iota whole square. So, minus iota by 2 into 4 into minus 1. So, finally, we are getting 2 iota as your z. 2 iota is your z. 2 iota is your z, that means beta will be equals to 2 upon 2 iota is your z, that means argument z is pi by 2. So clearly this is beta is coming out as what? 4 by 5, 4 by pi. Sorry, pi by 4 is already there. Pi was already there, right? So 2 iota pi is your z. 2 iota pi. Pi is already there. Pi cancels. So beta is 4. Correct. Beta is 4. Alpha is 1. So 1 comma 4. You're looking for distance of point 1 comma 4 from the line. So very easy. We just need to satisfy this point 4 minus and a perpendicular distance P is equals to mod of 4 minus 3 4s are 12 minus 7 upon 5. So this is going to be 7 plus minus 3, so 15 by 3. P is coming out as 3. Correct. 3 is absolutely right. Okay. All right. Yes. Do we have another question? Yes, we do have a last question. Last but not the least. Okay. Z1 and Z2 be the complex number. Z1 plus Z2 is given as 5. So very basic question actually. This is like class 10 problem. Sum of like Z1, Z2 is 5, Z1 cube and this is given as this and we're looking for this. Okay, just the equation solving. Identities. Use identities. Let's pick this. A cube plus B cube is A plus B. A square plus B square minus AB equals to 20 plus 15 iota. Okay. Z1 plus Z2 is given as 5. Now Z1 plus Z2 whole square. Sorry, Z1 square plus Z2 square will be Z1 plus Z2 whole square minus 2 Z1 Z2. So this will be 3 Z1 Z2. This is equals to 20 plus 15 iota. Let's cancel 5. 5 ones are 5. 5 fours are 5 threes are. So Z1 plus Z2 whole square, that is 25 minus 3 Z1 Z2 equals to 4 plus 3 iota. So now 25 minus 4 plus 3 iota is equals to 3 Z1 Z2. So this is 21 minus 3 iota upon 3 is equals to Z1 Z2. 7 minus iota is Z1 Z2. Now what are you looking for is Z1 plus Z2 power 4. Understand. Z1 power 4 plus Z2 power 4 is z1 square plus z2 square minus 2z1 z2 whole square. Again, z1 plus z2 whole square minus 2z1 z2 whole square. Okay, let's do one thing. Let's keep it simple. Okay, you have z1 plus z2, correct? 5. You have z1 z2 also. Why not we calculate z1 square plus z2 square? That is going to be 25 minus 2, 7 minus iota. So 25 minus 14, 6 plus 5, 11. 11 plus 2 iota. Let's put z1 square plus 11 plus 2 iota square minus 2, again z1 z2 whole square is 7 minus iota whole square. Okay. So now this is 121 plus 4 iota square, so minus 4, plus 44 iota minus 2, 49 minus 1 minus 14 iota. 121 minus 4 is 117 plus 44 iota minus 2, 48 minus 14 iota. Finally, you will get 117 minus 48. 117 minus 96 plus 44 minus 28. 44 minus 28. So this is 14 minus 8 is 6. 3 minus 2 is 1. Plus 16 iota. Correct. Now what about this? This is 11 minus 9 is 21 plus 16 iota. If you calculate it, okay, so you need mod of it, right? So modulus of this will become 75. Just have a look at the calculation. I'm just writing the final answer. 75, that is option B, is absolutely right for this last question. And we are done. Okay. January attempt done and dusted. Now one thing, 2024 PYQs, so we are doing it. What about 2022 and 2023? Just tell me. These PYQs will be actually, you can find them chapter wise. Good source of PYQ, you will find them in the description box. Tatva JEE Main booklets, physical books, physics, chemistry, mathematics, errorless solution. I highly recommend every one of you buy it, keep it with you, take it with your school, take it with your library, and keep it with yourself. Okay, so 3 years mandatory, you have to do it. 2024, so we are already doing it now. 2022 and 2023, you can refer this book. Also, if you are having any doubts, just ping me on Telegram t.me/Namrata Jaisinghani. Okay, and I will be there. I will be replying. Okay, I'll be solving your academic or non-academic doubts over here. Okay, chalo, this is me Namrata signing off. I'll see you all super soon in the next video. Do comment which video you want next in this series.